Everybody. Thanks for joining us. We're going to give people just another minute or so to jump in, and we'll get started. Thank you. All right, let's kick things off. Thank you, everyone, for joining us today. We're excited to have you with us. My name's Taylor Lund. I'm a manager of technical account managers here at GitLab, and joined by my colleague Jamie Reed, who serves the same position for a different team. We're grateful to have you with us this morning or afternoon. Just a couple of housekeeping items to get started. If you have any questions that come up throughout the presentation, please feel free to put those in the Q&A portion of Zoom. We'll get those answered for you throughout the session or towards the end, either by typing those answers back to you or Jamie. We'll have some time at the end to go through some as well. This webinar is being recorded, so you can look for that recording to come through into your inboxes in the next day or so after we wrap up. And with that, I will pass it over to Jamie.
Thanks, Taylor, and thank you all for your attention and time today. We appreciate you investing it with GitLab. So as Taylor mentioned, the purpose of today's webinar, what I intend to present here is really the story of DevSecOps in GitLab, how you can improve your application security testing and meet compliance and auditability requirements using our tool. With that, I'll share my slides and we'll get going. I'll reiterate as I get going here, feel free to ask questions at any point via the Q&A tab at the bottom of the webinar. We're happy to entertain those, and for any questions that we can answer live, we'll pause the presentation and address those during a couple of specific breaks. Like I mentioned, what I intend to focus on today is how GitLab can help you improve the security and the integrity of your application from an end-to-end basis. And we're going to focus specifically on the need to automate and shift left application security testing using GitLab secure capabilities, and policy and compliance and auditability using GitLab's capabilities to help you meet compliance requirements. Why are we having this conversation? Why talk about shifting left? If you weren't aware, finding and fixing vulnerabilities earlier is far less costly than once they reach your production or your mainline branch. The cost of remediation can increase by up to 15 times by the time you hit production. We can see here this on the left-hand side of the slide, some results from NIST's impact of inadequate software testing as part of the 2019 software development price guide. And on the right-hand side here, we see a chart from another analyst where the cost of remediation grows significantly at each stage in the process. So if you can avoid introducing a bug at the requirement planning stage or at the coding stage, you could save between 6 and 15 or even 30 times as much your cost in remediation. The problem here is that even basic application security is hard. Traditional AppSec tools were built more than a decade ago, before today's modern software practices and methodologies like DevOps were commonplace. As an industry, we need to get beyond the basic idea of simple shift left and giving devs a light SAST in their IDE. And we want to, as GitLab, lead us into a new era where security is baked into the software development lifecycle, using a single application, a single data store, and a single pane of glass purpose-built for the modern software factory. If you want to scale your approach to securing your SDLC, you need to empower your developers. An additional problem here is that modern software, compared to legacy application security, implies that changes must happen far faster. The goal today with software development is to deploy far more frequently, with more open source, more APIs, more external dependencies, and additional microservices. Things are getting complex. The idea of iterative development is often incongruent with the idea of full application security scanning as part of the process at the end of your process. DevSecOps doesn't scale without developer enablement, automation, and empowerment. As I talked about, the idea of next generation software also creates additional application attack surfaces. Software is composable, meaning network security becomes far less relevant. The idea of high walls and concentric circles, they're not going to cover you, right? You need to have a more comprehensive security scanning plan in place. Additionally, traditional application security tools are often usage-based pricing, meaning you're penalized for scanning more. To illustrate what I mean when I talk about traditional application security, here's a pictorial. So in a traditional process as a developer, you might push code to your repository, maybe run CI, and even use a merge request or a pull request to kick off a deployment pipeline, which then might hit a test environment. And at that point, you might be saying to your QA or your security teams, all right, this new version of the application is available for scanning. This all happens at the end of the process after the developers most likely moved on to their next task. With this scanning occurring so late in the life cycle, you're not empowering your developers to fix the vulnerability when they're most aware of it and when they're in that context, and it's easiest and cheapest to remediate it. So imagine for a second, if you would, a world where you could scan all of your code every time you commit it, make it seamless for the developer using fewer tools with dev, sec, and ops all on the same page, and keep your compliance auditors happy. GitLab offers this by offering a single application that spans your entire software development lifecycle, which includes application security testing. We're uniquely positioned to help you truly improve the workflow of both your dev and your application security teams. Let's talk about continuous application security with GitLab and all of the built-in security products that are available as part of our product. With GitLab, these security scans can be automated into every merge request. You no longer need to choose between risk, cost, and agility. Because you have one tool for the entire SDLC, you can use it on every commit. And on each of those commits, you can run all of these tests automatically. Additionally, GitLab offers the ability to create a review app so that you can run dynamic testing on working application code, all very early within your software development lifecycle. With this approach, there's no need to buy separate single solution tools. But if you've already got robust SAST or DAST tools that you've had around for a long time, you can reduce your costs and improve your speed to remediation by using them more sparingly and integrating the results within GitLab's merge request widgets. As you may be aware, GitLab operates across 10 stages of the SDLC. Within the secure stage, we offer functionality including static application security testing, container scanning, dependency scanning, license compliance, secrets detection, and dynamic application security testing. All of these can be built within your merge request so that as developers iterate on their code and collaborate with one another, they can also collaborate with your application security team and empower themselves to remediate these vulnerabilities before they make it into production. Let's talk for a second about managing vulnerabilities. Of course, this is everyone's favorite job. But what happens when you find 10,000 security vulnerabilities at the end of your cycle? All of your timelines might get thrown off, and you've created this huge debt for your AppSec team to work through. It's also difficult for the AppSec team to incentivize development, who's now moved on to the next task and accountable for other delivery timeframes, to go back and address this debt. So the idea here is to empower developers to deal with each one at the point where they're being introduced. This way you can focus on exceptions and not on managing spreadsheets or a database of known vulnerabilities. So now that you understand the why, let's talk about the how. If you'll think back to that other pictorial I showed, here's one that illustrates how we can arm developers and empower them to resolve vulnerabilities and permit your AppSec teams, your security teams, to focus on exceptions rather than dealing with findings on a one-by-one basis. So like before, your developer here may be working on a repository where they're pushing code and triggering CI pipelines. But with GitLab, now they can have a review app showing a functional and operational copy of the code deployed to an ephemeral environment where they can interact with the application to confirm their changes and run dynamic application security scanning against this short-lived review app. Additionally, this developer will be shown security test results directly within their merge request and within the pipeline itself. So by rolling these scans and displaying their findings in the context the developer is working, they're going to be most empowered to understand what new vulnerabilities they may be introducing, and even presented information about how they can remediate them. By operating in this virtuous cycle, then when the developer moves forward by merging the merge request and kicking off a deployment pipeline, the security team can still get visibility into what vulnerabilities have been introduced, may have been introduced either on an exception basis or otherwise to production. So they're not losing any agency or visibility in the process, but deploys no longer need to wait for something like a test or a pre-production environment before they can move directly to production. The key to our approach is scanning the code at the point of code commit. Before code changes ever leave the developer's hands, before you're merging a merge request and introducing new vulnerabilities into mainline branch. This ends up very powerful because it provides real-time feedback to the developer of any vulnerabilities in their code while they're looking at it and they're in that context before they've context switched and moved on to some other task. The developers themselves are empowered to understand and remediate the flaw in their code before merging it into main branch and before needing to involve others. As I mentioned, security still has agency and awareness of this process. And in fact, I think for most organizations, I would encourage the idea that security collaborate within the merge request itself as part of a review. And we'll talk a bit later about how you can enforce these types of reviews dependent upon the degree of vulnerabilities uncovered in a given merge request. Here's a bit more detail on the type of security scanners that GitLab makes available. So as I mentioned, we've got SAST and DAST for static or dynamic application security testing, which can help you detect vulnerabilities in your source code, like known SQL injection or object injection, cross-site scripting attacks. You can benefit from dependency scanning, which helps you detect known vulnerabilities in third-party libraries or components that your application may be reliant upon. And as I mentioned in an earlier slide, this is an increasing concern as you look to secure your software supply chain and understand your software bill of materials. Dependency scanning is a critical thing to be aware of. As the next Log4Shell type vulnerability emerges, you're going to want to be able to understand any third-party dependencies that are baked into your production apps and whether or not you're vulnerable. Secret detection, another important one in today's software development landscape. This helps you detect credentials, secrets, or passwords in source code before you merge them in a mainline branch. And you can also optionally run the scan as part of a pre-push or a pre-commit hook, which will help you ensure that these types of secrets never make it into the repository in the first place. We also offer license compliance, which can help you build a policy around approved or disallowed licenses defined by your custom policies. We also offer container scanning, which like dependency scanning, helps you detect known vulnerabilities within container images that your application may be dependent upon. We recently introduced infrastructure as code scanning, which can help you scan your Terraform, Ansible, CloudFormation, or Kubernetes configuration files or Kubernetes manifests for known vulnerabilities. And on the runtime side, I mentioned DAST, but I'll also mention here coverage-guided fuzz testing for both web apps and also API fuzz testing for APIs. Here's what this looks like within a pipeline. So as a developer working in a project, as you kick off a pipeline, what you'll see here is security ends up embedded in the pipeline before the code even ends up merged. So if developers are working in the context of a merge request, which is really the point of collaboration, right, where the developers' commits end up coalescing with a code review and security scanning and any other pipeline components that you define, what we can see as part of this pipeline here is a build process where the developer's push gets built, and then a number of different tests, including some security scans here, container scanning, dependency scanning, license management, and static application security testing, all running against this proposed version of the code before it's been merged back into mainline. Once this test stage completes successfully, the pipeline will then move on to the review section, which deploys a short-lived or an ephemeral copy of the app where the developer, application security, and quality assurance can all interact with a short-lived version of the application itself. And then here, the DAST scan runs against this short-lived copy of the review app here. I'll pause here for some questions. I see a couple filtering in, and I think this is a sensible point to address any questions that have come up because I've already covered a lot of ground in terms of the scanners available. I see a couple of questions here related to what is IAST. Let's pause and take some of those. So one attendee asked, what is IAST or IAST? That's infrastructure as code scanning, right? So that's scanning either Terraform, Ansible, CloudFormation, Kubernetes manifest, those types of configuration files that offer you a declarative way to configure your desired infrastructure. You can run scans against those to ensure that you've got a secure configuration set therein. I see another attendee here ask for some differences between GitLab security scans versus those by like a competing vendor like a Fortify. While I probably won't be the best first to dive into all of those details, what I'll do is direct you to our docs page where you can learn all about the different types of scanners that GitLab wraps and develops ourselves and how those scans might differ from like a Micro Focus Fortify. But like Micro Focus's Fortify offering, we offer static application security testing for a huge bouquet of different languages. So these help you detect potentially vulnerable patterns in the code you've written by scanning them on a static basis. The third question I see asked here was, do we have templates for these types of tests and scans to run in the CI/CD pipeline? That's an emphatic yes, and I will certainly lean on Cody, Sean, or Matt to share the appropriate documentation link here. But probably the best place that I would start would be to take a look at our Auto DevOps template, which is actually just a composed selection of different different CI templates that include things like security scans. So you can grab components like the security scan template that Auto DevOps calls to then use and really get like a pre-baked version of exactly this. So when we look at the slide I'm sharing here, this test stage can be included by grabbing a copy of the templates, which we publish on GitLab.com, and all of those tests will run automatically. I'll invite my colleagues, Sean, Cody, or Matt to correct or augment anything I've shared here, either in chat or live if you prefer. Cool. Well, moving on, let's talk about enabling developers to address these security findings. So we've talked a bit about what scanning looks like in the context of a pipeline. And now I want to show you what it looks like in the context of the merge request itself. So in this slide here, we have a screenshot from a merge request. And this one is labeled WIP or work in progress. So the developer here is still actively working in this branch. And by tagging it as WIP, they're indicating to their colleagues and the rest of the team that this is not ready for merge. It doesn't require yet, say like an application security review, and they're just actively working this merge request before they're really ready to say, hey, my code is, my branch is ready for review, and let's talk about when we push it to, merge it back to main, let's say. So this request to merge here, which is the feature branch the developer is working on into, in this case, the master branch, has a pipeline that is run on it and has a required approval here. And we'll talk a bit more about what these types of required approvals mean, but you can configure either by way of the now deprecated vulnerability check or the new scan result policy editor that GitLab introduced in the last few months, the idea of required approvals. So for example, if you wanted to build a pipeline that required approval from a group of like application security professionals or maybe a backend maintainer, in the case of a specific level of vulnerability being uncovered, you can configure that. And this merge request will then, based on the results of the security scans, set up a required approval. If there's no security scan results or findings above a certain configured degree of vulnerability, that approval won't be required. So this helps developers move forward with a bias for action, but also ensures that if you don't want to introduce any, say, high or critical vulnerabilities into mainline branch, that you offer that check in the process to say, whoa, before you hit merge, let's make sure that an appropriately credentialed member of the team reviews the change you're proposing. But the real value of the merge request view here is in the latter two rows. What we can see here as part of what we call merge request widgets are the results of the security scans that have executed as part of that pipeline view I showed in the prior slide. We can see here in this proposed change that the security scanners that ran as part of the pipeline detected 24 new vulnerabilities, and that either the developer or application security has already dismissed 4 vulnerabilities. So as part of the findings, you can actually click expand here. You can also jump out to the full report, which will show you the job log of the scanner itself, or by clicking expand, you can jump into the type of vulnerabilities found. And I'll show you that view here. So for example, if you click expand in that merge request, what you'd be shown here in a developer-friendly way is a drill down view of the findings that, say, SAST and other scanners had found. So in this case, the SAST scanner had found a selection of medium and high severity vulnerabilities. One of these high severity vulnerabilities was actually dismissed as something that didn't require remediation. So this offers you the ability to, on an exception basis, override a finding and move forward if everyone agrees that that's a safe thing and a good thing to do. This helps you integrate best practices within your DevOps workflow and provides automated security workflows that are adaptable and non-blocking. These are all executed through GitLab's CI, or continuous integration engine. And within both the pipeline view and the merge request itself, developers and application security professionals get that visibility. They get that agency in the process. And it really dramatically limits the cognitive load and the cost of context switching, which can be very disruptive. So let's imagine, for example, that as a developer, you had a finding and you wanted to actually take action on it. If you were to click into one of those vulnerabilities that I showed on the prior slide and drill into it, you would be presented with what we call a vulnerability page. Vulnerabilities are first-class objects within GitLab. Just like an issue or a merge request or an epic, they're their own data type that really, they're their own unique first-class thing that you can manage within GitLab itself. So with an ultimate license, developers can choose to dismiss this vulnerability with a comment. They can also alternatively opt to create an issue to acknowledge the vulnerability and create a call to action for this particular vulnerability to be addressed. Or they can opt to go back to their merge request and address the finding directly in the MR by pushing another commit. How might they do that? Well, within this vulnerability page, there's a number of different links, including one to the CVE here and one to a page with some detail on, in this case, a serialization vulnerability. So if they wanted to understand where this finding occurred, and looks like this finding was as part of a POM XML in a Maven project, and our scanner, the Gymnasium scanner, is calling out a known vulnerability within one of the dependencies that they've pulled in here. So the socket server receiver component as part of this vulnerability is known to be vulnerable, and the developer could simply, they're even presented with a proposed solution here. So if you want to remediate this finding, simply upgrade your POM XML to pull in the most recent version of this third-party logback core library. Beyond just linking the developer to resources to understand the vulnerability and providing details as to what the solution might be, we also offer quick remediation with automatic remediation for select dependency scanning and container scanning findings. So in this case, the container scanning scanner here has uncovered a known CVE from 2019 from Adam's project here within one of his third-party dependencies. And in this case, he's pulling in a known vulnerable version of the musl or MUSL dependency. The solution here would be to upgrade your musl dependency from 1118 to 118R3 to 1118R4. And again, for select findings, when you open up the vulnerability card, you can opt for auto remediation. So you click resolve with merge request, which is going to automatically open you up into a web IDE and show you directly that line that you should change and how to change it. And you can add that to a fresh merge request to address this vuln. So that's what the workflow looks like. Now I want to talk a bit about the visibility that GitLab can offer to different teams so that application security professionals that may have joined us in the call here today understand the part that they can play and the reporting that GitLab can offer. GitLab offers visibility into your security risk via what we call our security dashboard. This allows either directors of security or CISO types immediate visibility into a group level security posture. So they can understand quickly any at-risk projects with security grades. They can see a burn down chart of vulnerabilities over time for the given group. And for a given project, they can see the different types of grades, A through F, based on the number of high or greater severity vulnerabilities per project. So this offers you that fulsome ability to understand and manage your security risk across your entire organization. These types of high-level trends and metrics provide that insight and that data to support decision-making and help you understand your stance. Here's a screenshot, an example, and really an example of what the vulnerability report looks like at the group level. So if you were to drill down to a specific group and click into the vulnerability report, our group security dashboard provides an overview of all vulns across all projects in that group and its subgroups. You can drill down into a vulnerability to view the related information, such as the affected project or the file where the vulnerability occurs, and offers you additional metadata and links and resources to help understand the risk. Each of these records allows for the following actions. You can get more info. You can also dismiss a finding, or you can create an issue to, again, build that call to action and encourage a team or a developer or an application security analyst to address the finding. This security dashboard is updated once a day based on the most recent scan of each mainline branch for each project. Here's the project level view. So the project security dashboard displays the results of the most recent security scan on the default or the main branch of the project. You can use it to find and fix vulnerabilities affecting that branch. And the display of this report reflects each and every time the mainline branch pipeline has been run. You can also, using scan execution policies, schedule regular recurring runs of pipelines for projects to ensure that the information you're looking at here is up to date. The dashboard itself supports container scanning, DAST, dependency scanning, and SAST findings. Really all of the scanners we wrap here, including secret detection. The list is long. All of these will show up here in this vulnerability report at the project level. So from that dashboard view, if you were to click into a vulnerability, you'll be presented with that same vulnerability page, right? So you can navigate back to that first class object to say, here's the vulnerability itself, where it was detected, at what time. So this, in this case, pipeline 33745, as part of this project, discovered an RCE and patch request for a Spring Data, Spring Root library. So our dependency scanning scanner using Gymnasium uncovered this as part of the POM XML for this Maven project. Like I talked about before, you can manage the status of the vulnerability from this page. So by default, it's going to be detected, right? Scanners have uncovered this vulnerability. That's the new state of this finding. But from there, if you wanted to have more of like an approvals-based process where an application security team reviewed the findings for the project, you can also change the state to confirmed. So this, if you have a model where application security wants to pick up on findings rather than have the developers triage them, you can use this to say, all right, we won't triage anything until the AppSec team has had the chance to review the finding and confirm that this is something that needs addressing. So that's the status there of confirmed. Alternatively, that same team member could change the status of this vulnerability to dismissed, which indicates that somebody has reviewed this and dismissed it, meaning it does not require a remediation. Finally, there's the status of resolved, meaning the vulnerability has been fixed and it's no longer in the code base. Additionally, as I mentioned before, you can also create an issue here, which helps build that backlog of work that you can use as part of, say, an agile planning process to ensure that you're building the bandwidth into your process and folks have the right call to action to address these vulns. That's a quick overview of the security reporting and dashboarding functionality that GitLab includes. And I see, Cody, you jumped onto video, so perhaps there's a few more questions we want to address live. If that's the case, feel free to voice them over and let's see if we can answer them. I see a couple of Q&As going, so I'll leave those asynchronously in the chat. And for now, I'm going to highlight a couple of additional resources, and then we'll jump into compliance as time permits. So I talked about SAST, or static application security testing. And if you're not familiar, what this is a process that will analyze your source for known vulnerabilities. So it looks at patterns that are known to be vulnerable. And GitLab supports a broad array of different languages and frameworks. So within these slides that I'm sure will be packaged with the recording, you can see here for the type of language you might prefer, this scanner that we wrap and that we use. So in the case of secret detection, we wrap Git leaks. In the case of something like Go, we use GoSec. If you're a Node.js developer, we use Node.js scan, ESLint for JavaScript. I won't read the whole slide, I promise, but there's a quick overview of the different types of SAST scanners that we support. I mentioned container scanning. So what this is really static analysis on the Docker images themselves to detect known vulnerabilities in third-party dependencies that these images may pull in. So this analyzes the image contents against public vulnerability databases. We use Trivy, and I think formerly Claire, as part of Aqua's offering, which is an open source tool that helps us analyze or scan any type of Docker or AppC image. And like other scanners, these findings, these vulnerabilities will be presented in line in the merge request as part of all of the dashboarding and reporting tools that I mentioned already. Next up, we've got DAST, which today wraps OWASP's Z-Attack proxy. This helps analyze running web applications. So as part of an ephemeral deployment of your web application, DAST can be run to detect any kind of runtime vulnerabilities that may not have been uncovered as part of static scanning. Like all other scanners, these vulns are also shown inline in the merge request. Let's talk briefly about license compliance. So again, we offer license compliance scanning for a whole variety of different languages shown here. And these search your project's dependencies for the respective licenses of those dependencies. This can help you detect and, on a policy basis, disallow undesired licenses. Like if you don't want to copy left license that might infect your code base, you can disallow certain types of like AGPL type licenses if that was something your business wanted to avoid. You can create a license check manual approval. So I mentioned before, and I showed a brief slide about the vulnerability check. There's also a license check or a license approval policy you can set to require approval from, say, a legal team member or another appropriately credentialed team member to ensure that any licenses being brought in as part of new third-party dependencies are checked before they become part of your code base. Dependency scanning. So this is a big one, right? As you try to understand your bill of materials when it comes to your software, more and more enterprises are now relying on third-party vulnerabilities, third-party libraries and open source software to build their products. Dependency scanning helps you analyze the third-party dependencies you're pulling in for known vulnerabilities. You get a dependency scanning report. We also offer a software bill of materials report now, which can help you understand the different types of dependencies that you're pulling in. Here's that SBOM bill of materials view, where you get a report based on a per project basis that can show the dependencies this project is pulling in. So as mentioned, this bill of materials makes the information available and accessible so that, say, a compliance team can review and perform validation on the app, and you can understand your potential risk footprint. We haven't talked much about fuzz testing yet, which was an acquisition of GitLab's a little while ago. And this can also help you detect more vulnerabilities, other defects, not as easily uncovered by something like SAST or DAST. So the idea behind fuzz testing is it helps you test deeper and wider than prior types of scanners, and can help you find unknown or unanticipated software defects by doing things like inserting malformed inputs. It can also additionally help you monitor for your application's stability and reliability in the presence of these unknown or unexpected inputs. It can also help you minimize false positives and improve your root cause analysis from something like DAST findings. As you shift left by adding coverage-guided fuzz testing, you can ensure that this type of scanning happens from your first line of code that you commit. Before we get into compliance, which we've got about 20 minutes to cover here, I will pause for any Q&A. I don't see any open questions, so it looks like things have been answered, but I'll give a brief 10-second pause here if that's not the case. All right, we'll skip past the thank you and we'll jump right into compliance. So we've got a few more minutes, and I thought I'd cover some of GitLab's compliance capabilities, which are pretty complementary to some of the security capabilities I mentioned here today. So if you've got interest in security and compliance and governance within GitLab, what I wanted to highlight here was that GitLab can help build security and compliance into your workflow and leave it within your single application approach. It can help you by way of the single application. You get a single permission model and user model and data model, which can help simplify auth-N and auth-C management to ensure that you're enforcing things like separation of duties and make audit of these type of controls much easier. As I mentioned, expediting auditing, right? So you can verify your compliance with your required controls in far less time. We'll talk a bit about audit logs and audit reporting throughout this process here. And this gives you control. You can act with certainty. You can control how code is deployed and eliminate guesswork in how you are building compliance into your application development lifecycle. So compliance without friction. What do we mean when we say that? We have a whole list of different controls we can help you address, including things like separation of duties, identity and access approval controls, configuration management and change control. The list is quite long there, and I promise I won't read it all. But if you've got FSI, PCI, SOX, HIPAA, GDPR compliance needs, GitLab can almost certainly help. GitLab itself is a secure application, and we can help you secure your SDLC. When we talk about compliance management with GitLab, the aim here is to help change the current paradigm to create an experience that's simple, friendly, and as frictionless as possible by enabling you to define, enforce, and report on compliance policies and frameworks. So if you're still with me, if you haven't fallen asleep yet, I'll talk a bit about how we do that. Through the definition of policy management, so meaning you're setting rules and policies to help adhere to the compliance frameworks you desire, you can identify select projects that you want compliant with these controls. You can enforce these compliance controls by way of what we call compliance pipeline configuration. And I'll talk more about that in a second. And then finally, when it comes time to prove it, right, on the reporting side, we've got audit management capabilities, including reporting, as well as an audit stream that you can send to third-party systems if that's your preference. So when we talk about rules and policies, there's a whole bouquet of different things that you can use, like merge request approvals, and scanning policies, and bill of materials, and push rules, and these different things that can help you create a policy management control across your org. So you get very granular user roles and permissions management, 5 different role types within GitLab. And in our roadmap, we've got all kinds of interesting role-based access control improvements coming, so watch for that in future releases. We've got compliance pipeline configurations. We've got a credentials inventory, which can help you manage and keep track of all credentials that can be used to access your instance. And we have the concept of protected branches, which I won't touch on today, but if you're curious, I would encourage you to review our docs. Let's talk a bit about compliance pipeline configuration. I'm going to jump ahead to one more slide here and talk about automating different compliance workflows. So when I say that, what I mean is how GitLab helps you manage your compliance by enforcing CI automation jobs to execute on projects that must meet select regulatory requirements. So using the compliance framework configuration within GitLab, externally to the project, you can define pipelines that then can be applied by way of a label to select projects. So what I mean by that is, using something like separation of duties and a separately controlled project with maybe more selective access and permissions, you can define a separate YAML file that then you can apply to certain projects that will be run as the only pipeline. Within that YAML file, you've got the optionality to offer and include to that project's GitLab CI file. So for example, if you just wanted to enforce maybe one or two required scans or reporting type activities that must happen as part of the pipeline, you could certainly do so. But you can still also offer developers the autonomy and the opportunity to operate with a bias for action and agency over their own pipeline configuration by including the GitLab CI file as part of that compliant project itself. So there's a lot of optionality in how you build this, but the real takeaway here is that you've got the ability to enforce required pipeline jobs as part of different projects. These are immutable definitions that are executed according to this framework, regardless of what developers or maintainers within that project themselves do. So there's provable compliance here. Beyond the idea of controlling the configuration of the pipeline itself, there's also required approvals. So we've talked a little bit about this in the form of things like vulnerability check and license check, both of which are evolving a little bit to move towards things like scan result policies, and review our docs for a bit more details on that. But the idea in a compliance context here is that you're streamlining the approval process within the merge request itself. So these screenshots here on the right show the approval section of the merge request. So that if you wanted to build a process by which any change to the project at all required things like an eligible user to offer approval, or they must pass muster with code coverage, license scanning, and vulnerability scanning results here, or perhaps you wanted to offer the use of a code owner's file to control select folders or files within a project to require select approval. And there's also the idea of status checks, which we won't talk much about, but in brief, what status checks are is the ability for your pipeline to reach out to third-party systems. So maybe you had a third-party system for change approvals that you wanted to make sure that ticket was closed out before this merge request could merge. You can build that in as an external status check, which can illustrate within the merge request itself whether the external systems should suggest moving forward with the merge. All of this is contextualized within the merge request itself, right? So the developer gets a single actionable view of not only the output of their CI jobs, but all of their security scanning, license management, test results, code quality, performance testing. It's all shown within the merge request. So the developer, maybe their coding partner, or code reviewers, maintainers, application security professionals, they all get this view before that merge request moves on. Finally, the exciting piece that everybody dreads, I would say, but is also a pretty important part of compliance posture is auditing, right? So satisfying that organizational requirement to prove things like separation of duties. And GitLab can give you information about who took action, what action they took, what occurred, why was that action compliant, who authorized that action, where and how long did it last, what gaps may exist. GitLab's audit event capability helps answer those audit logging requirements within either the UI or our API. Within the last 3 or 4 months, GitLab also introduced streaming audit events for Ultimate license customers. So you can actually redirect a webhook-based stream of audit events to an external logging tool like Splunk, for example. Here's a quick view of the compliance dashboard. So within a given group, you can click into security and compliance and view the compliance dashboard, which helps you understand recent merge request activity within that group. So across all projects, what's changing, who is changing it, and what approvals were in place when that happened. This is the last slide, so congratulations if you made it through the compliance and auditabilities portion of today's presentation. This here is a good link dump, so if and when you get a copy of the slide, you can use this to reference our docs for a number of excellent resources for additional details on all of the capabilities I've discussed today. With about 5 minutes remaining, I will certainly thank you for your time and attention in watching me present. I hope everyone learned something new and exciting, and I'll hand it back to Taylor for a bit of housekeeping before we wrap for the day.
Great, thanks, Jamie. I'm going to go ahead and submit or launch rather a poll. I just did that. Would love to get your feedback from today's session. Just a couple of quick questions there. Go ahead and submit those. That would be greatly appreciated. And while we're doing that, Jamie, I think there are a couple other questions in Q&A as we have a few more minutes here. If you wanted to jump in and go through a couple of those.
Sure, happily. The first one I see in the list here is, how do I know which GitLab subscription our company is using? We have a customers portal. So if you go to customers.gitlab.com, you can create an account there and log in and understand the subscription tied to your company's namespace in the case of gitlab.com, or tied to the subscription owner in the case of a self-managed instance. So ideally, the account owner that was stipulated as part of the purchase order, if it was a sales assisted order, will be able to do that. In the case of a self-service order, maybe you just dipped your credit card and bought a couple of seats, you should be quite familiar with the GitLab customers portal already. Additionally, if you go to the fully qualified domain name of your GitLab instance /help, you'll be shown, if you have administrative rights, some information about the version your instance is running, as well as the license present on that instance. And in the case of a GitLab.com subscription, if you go to your GitLab.com namespace, go to settings, and then click billing, you'll also be presented with information about the subscription, its renewal date, and other pertinent information about that relationship you've got with us. Thank you for your business, and thank you for that question. Last question I see here was, do we have recorded training videos, kind of crash course on DevSecOps with GitLab's YouTube channel? I think the answer there is almost certainly yes. If you're not familiar, we've got the GitLab Unfiltered YouTube channel. It looks like maybe that got answered. I haven't read the answer, so I'll offer that caveat, but I will say that beyond what was offered there, we also have our GitLab Learn portal. So if you Google GitLab Learn, you can land on about.gitlab.com/learn, where we offer a whole variety of different paid as well as free courses. So there's a couple of free GitLab 101, GitLab 102 type level courses, as well as some information on security scanning with GitLab. The final resource that I'll point out before I wrap for that question would be the field marketing webinars that we advertise on our website. And I'll just Google GitLab workshops. If you're hungry for more information and perhaps some more hands-on experience with, and let me see here, I'll say type answer. Oh, actually, I'm not sure I can offer a kind of an ad hoc link in the Q&A. I perhaps can't, but if you Google GitLab events, we have a whole running calendar of different either field marketing or solutions architecture sponsored webinars in addition, or workshops rather, in addition to the Scale TAM webinars, like the one you're attending currently. There's a 3 to 4 hour workshop, including hands-on experience with DevSecOps pipelines that our field marketing organization offers on a regular basis. In fact, I think there's one concluding today, but check that events calendar for the next upcoming session. I suspect in a month or two's time, there'll be an opportunity for that. I can highly recommend that one. That's all I've got. And I'll say again, thank you very much for investing your time and attention. That's your most valuable resource with us today. Hopefully you found it useful. If not, we always appreciate constructive feedback. And I'll hand it back to Taylor for the wrap.
Yeah, thanks everybody. Thank you, Jamie. Like he said, feel free to check out future sessions like this. Would love to host you again. And with that, hope you have a good rest of your day, everybody.